right, so they're asking which one's the largest and smallest. I'm going to put it all the way across. I'm going to go biggest to smallest. Well, the biggest one must be the number plus 3. This is the biggest side. So the angle across from the biggest side must be the biggest angle. So we are going to have measure of angle A. Has to be the biggest. And then it's bigger than, well, x plus 2 is the next biggest size. That one is across from angle B. So measure of angle A is bigger than measure of angle B. And finally, the last one must be measure of angle C. Questions on that? Just because I was doing it at the end of the year, we're going to continue doing this. I'm going to answer questions from the homework at the end of the lesson. That way people that don't have questions can just not have to sit there and listen to me explain stuff that they know. They can just start at the homework. And if you have questions, you just wait to have those answered. So we're going to go into today's lesson, but you're going to notice today's lesson is very similar to what we did yesterday. We're just expanding it into 2 triangles. So this is inequalities for 2 triangles at the same time. However, to use 2 triangles, they must be similar in some fashion. We're just not going to compare 2 randomly different sized ones. So we're going to begin with 2 matched pairs of sticks joined loosely at B and E. Open them so angle B is bigger than angle E, and you will find that the distance between these ends, since angle B is bigger than angle E, this distance from A to C is going to be longer than this distance from D to F. It is just kind of a fact that if this 2 things are the same size, the 2 sides are the same size, that opening it further, a bigger angle is going to create a bigger side. I'm going to show a quick demonstration with just rulers instead of just the drawing. Do you agree that these 2 are the exact same length as these 2? Okay. So in this example, I have 2 rulers, and I open up this side. Picture this distance, not very far. So this is one triangle. Picture this as one triangle. I'll create that into a triangle, possibly.
You sure just drawing from the inside of the rulers?
It's too late now. The damage is done. Alright, so we have that one triangle. Now I'm going to take the exact same 2 rulers and open them up wider. Same size, right? Same rulers. I'm just opening it up to a different angle. The only thing difference between these 2 is this angle. This one's smaller, this one's bigger. The one with the bigger angle is going to have a bigger side opposite. But in order to have that happen, this side must be the same as this side must be the same as this side. This is what's known as the hinge theorem. This is known as the hinge theorem, and that's right down here. The hinge theorem and converse. Well, the hinge theorem is this one, the bottom one is the converse. If 2 sides of one triangle are congruent to 2 sides of another triangle, that has to happen. Just like with the rulers, I need both triangles to have 2 congruent sides. So that's pretty important for this thing to work. So we need 2 sides, so congruent to 2 sides of another triangle. So basically we need 2 congruent sides for both triangles. And the included angle, the hinge angle of the first angle, is larger than the included hinge angle of the second. Then the third side of the first is longer than the third side of the second. It's just a lot to say what I just showed with those 2 rulers. And let's look at the example off to the right-hand side. This is also called the side angle side inequality because you do need this side. You need 2 sides that are congruent, and you need to know something about the angle between. If the angle between is the same, then they're going to be congruent triangles by side angle side. Can't remember if that was a theorem. Yeah, I think that was a theorem. That one was a theorem. So side angle side, if they were the exact same, they'd be the same triangle. If one angle is bigger than the other, like in this case, then we know something about that third side. So we look at those two triangles that are over here. We look at VWX and RST. Do they have two congruent sides to each other?
Yes.
Yes. I was just looking for some kind of, like Ethan shaking heads that look like blank stares. Like, I don't know. Yes, they do have two congruent sides. VW is congruent to RS, and VX is congruent to RT. That is the requirement to use this theorem. I need to have two congruent sides, and I need to know something about the angle between them. The angle between them. If T gave me T and X, I couldn't do anything with it. I have to know the angle between them. So, in this case, we know that VW is congruent to RS, and we know that Vx is congruent to RT. Now, since the angle between those two, in other words, since measure of angle V is bigger than measure of angle R, the sides opposite will follow suit. So the side opposite V is WX. So it will follow suit that WX is larger than the side opposite angle R. The side opposite angle R is that ST. That is the hinge theorem. But you have to have side angle side for this theorem to apply. If anything fails in that, like it's an angle off to the side, you don't know two sides are congruent, then you cannot use this theorem. Side angle side is the hinge theorem. In the book it's theorem 6.5, but when you go in the real world you can't say it's theorem 6.5 because no one knows this is in chapter 6. So more well known is the hinge theorem. Now we just go to the converse. The converse is pretty much the exact same thing, except it's the converse of it. This time I'm going to know two sides are congruent. So if we look at the triangles over here, I know two sides are congruent. Rather than knowing the angle between them, I know the side opposite the angle between them. I know that size. So if we look at that 12, that is the side opposite the angle between them. This 9 is the side opposite the angle between them as well. So I'm going to quickly rattle this off. If two sides of one triangle are congruent to two sides of another triangle, starts out the same way. And the third side of the first is longer than the third side of the second. That's what we have. 12 is bigger than 9. Then the included angle, called the hinge angle of the first, is larger than the included angle, the hinge angle of the second. In other words, so we have two sides that are congruent, just like we had up here. So we had that AC is congruent to DF, and we have that CB is congruent to FE. And since 12 is bigger than 9, so in other words, AB is bigger than DE, AB is across from angle C, so measure of angle C must be bigger than the side opposite DE. The side opposite, or angle opposite DE, is going to be angle F. I like these theorems because they're pretty tangible. Like you can kind of picture them with the two rulers. But the key is with both of these is you need to have two congruent sides of the triangles, and you need to be talking about the angle between them. Whether it's the side opposite the angle between them, or you're directly talking about the angle between them. Do not forget about that, because I can definitely on the test put, you know this side, you know this side, you know this angle, you know this side, you know this side, you know this angle. What do we know about DE and AB? You won't know anything then. If it's in the wrong place, you don't know anything according to this theorem, so you'd have to just put that. All right, questions on those two theorems? Just itching? Can't itch that fast. All right, so some examples really quick. So it says, complete the following statements using less than, greater than, or equal to. In this case, we're talking about AC and EG. Let me highlight those two things with red. So we're talking about AC and EG. In order to use this theorem, I need to have two triangles with congruent sides on both of them. Well, let's look at this one. Well, I have a 14 and a 14 on this triangle, and I have a 16 and a 16 here. So they do have two congruent sides, so we can use that theorem as long as we're talking about the angle between them. 32 is definitely between this 16 and 14, and this one is 32. If the angle between them is congruent, that means the two triangles are actually congruent, and our two sides will also be congruent. So this is going to be AC is equal to EG. Erase that. My next one is AB and FG. AB and FG. Well, AB, let me highlight it, is across here. FG is the one across here. I need two sides that are congruent. Yes?
No, is it like the 16s?
Yep, it is going to be those 16s. So we're talking about these triangles basically. And that this 16 is congruent with this 16. This 16 is congruent with this 16. In fact, all four of them are congruent. Then we just look at the angle between them. One is 116, one is 110. Since 116 is bigger than 110, that must mean that FG is bigger than AB, but in this order, it's going to be AB is less than FG. Yes?
I kind of have a question about, like, so if those two sides are the same, like, how come, like, it wouldn't be, like, why would it have to be 100 and 116? Like, why couldn't it be, like, 116 and 116 or 100 and 100? Because the 16s are, like, the same, so, like, wouldn't they be the same measure? So, like, because, like, their 16, like, would equal that angle, and 16 would equal the same angle. 16 would equal angle B, A, F, and G. So wouldn't they be like, shouldn't 116, like, those angles be the same? Or?
Well, nothing's to scale. Just got to take those numbers as given. Doesn't matter if it's right or wrong. Doesn't matter if it makes sense or not. You just take the numbers that are involved. So I think what Sabrina's saying is, hey, these are isosceles triangles. So these two angles need to be the same size as these two angles, and so you'd actually have similar, you'd have the same triangle, in short, is what she's saying. And you would. But because it's 116 and 110, you have to use numbers given to you, so we are going to stick with that AB is bigger than FG. All right, if BE equals 12, so let's write that down. If BE equals 12 and EG equals 8, then measure of angle BDE, so we're talking about, let's do that, measure BDE has what to do with EDG. So that would be, let's do that in purple. I'm checking for two congruent sides. I have 16 and 16, that's one congruent side of the triangles, and we also have 14, 14. So they do have two congruent sides. Now we look at the angle between. Well, that's not what we're trying to figure out, so we're going to look at the sides. One is 8, and one is 12. 12 is bigger than 8, so the angle opposite 12 is going to be bigger than the one opposite 8. The one opposite 12 is going to be BDE, so BDE is bigger than EDG. And the final one says if EG equals 8. So EG already equaled 8. And CF equals 8. So we have CF equaling 8 as well. Then CDF, let me erase some of these lines here. So it says then CDF has what to do with EDG? Well, we have two congruent sides. We have 16, 16, 14, 14, and the last side is 8, 8. So those two angles must be congruent to each other. So that's going to be a nice equal sign. All right, I want you to go ahead and do the rest. So you're going to try that A, B, C, D, E, F, and G. G, just match, just draw arrows. On our way. So the first thing we're doing, we're checking to make sure we have two congruent sides. I do. Triangle ACB has side CB and FE congruent with DF and that. And then we see that angle C is smaller than 110. So the side opposite 110 must be the bigger side. So you should have said AB is smaller than DE. And the next one, we have two sides are congruent. The angle between is also congruent. So that must mean the two sides are congruent. In fact, we know whole triangle's congruent because the side angle side. The last one, the next one, yeah?
Is it impossible?
It is impossible. If you did this one, good on you. I only see one side is congruent to another side. I don't have a second side. So you cannot do this one. We do not know what 2 has to do with 1 because I did not give you enough information. Yes?
Well, couldn't you say like 8, like you draw the 8 to the, like what, like you did in one of the lessons where you drew the side and you drew it to that angle, and you took the other side and you drew it to like the other angle, and so like 8 is like a bigger side, so that would make like 2 the bigger angle?
Sure. If we knew that 2 sides were congruent on both the triangles. You need to have 2 sides being congruent in order to do anything else with these hinge theorems. This one I know, this side is congruent to that side. You need to have 2 sides being congruent in the triangles. So the only way I could say that 1 is smaller than 2 is if I would have put dashed lines here to say that this side is congruent to that side. You have to check for 2 congruent sides. All right, moving on. I have 2 congruent sides because I have the ones that are marked, and I also have that shared side there. We're going to see that 6 is equal to 6, so measure of angle 1 must be equal to measure of angle 2. Our next one, again, we have 2 marked sides that are congruent, and we have the shared side. And then we look at 95 and 98. The side opposite 98 must be the bigger one. That is LS, so we're going to have MS is smaller than LS. Finally, we do again have 2 triangles. We have 2 sides that are congruent. One with 1 tick mark, one with 2 tick marks. We look at this 8. It is across from this 2, and this 9 is across from 1. 9 is bigger than 8, so angle 1 must be bigger than angle 2. All right, continuing on. These are the answers to this. Number 1 should have been D. Number 2 should have been A. Number 3 should have been B.
Is it C?
And what was that?
Is it C?
Is the last one C? Yes, nice. And the last one is C. Are there any of those we want to go over? Yes, Sabrina. Number 1. Okay, so it says AB is congruent to BC. So we'll go on here and say AB is congruent to BC. It also says that angle 1 is bigger than angle 2. Well, if we look at the triangles formed, I have this one triangle. I also have, gentlemen, I also have this triangle. And they do have 2 sides that are congruent. We have the one we just said, and this one. It says that measure of angle 1 is bigger than angle 2. If angle 1 is bigger than angle 2, so that must mean this side is bigger than that side. So we hope that we have one of those. And D is AE is bigger than EC. That is the end of the lesson. Homework will be due on Monday, but what I'm going to do right now is homework questions from 6.4. Sabrina.
For number, I was confused on number 17.
17.
Wait, so this way. Oh, sorry. Not off top.
We are number 17. No, you got to wait till I'm done with everything. Because it can't hurt to actually see some of these. So number 17, you had to do it by triangle by triangle. So we were asked to put all of those angles in order. What I did is I looked at this triangle first. I looked at the triangle with angle 2 and 1 in it. I looked at that triangle and I ranked the possible angles. And I looked at the sides and I said, well, 15 is the biggest side, so measure of angle 2 is the biggest angle. So angle 2 is bigger than angle y, because y is across from 12, and finally it's bigger than angle 1. So I ranked that entire triangle. Then I took this entire triangle and I did the big triangle to rank x, z, and y. And I said, well, measure of angle x is across from 15, so measure of angle x is the biggest. My second biggest is the one across from 14, and that's our x, z, y. And finally is bigger than measure of angle y. And then I looked back up here and I said, well, measure of angle y is bigger than measure of angle 1. So I know measure of angle 1 falls after this. The only one I have concerns about is measure of angle 2. Where does this fall on there? So if we just use a little common sense, x goes to the exact same side as 2 does. So we're going to know that measure of angle 2 must be bigger than x, because they're going to the same place, but this one's further out. The further out I go, the smaller that angle is going to be. And the closer I get to that same point, the bigger the angle has to be. So as soon as I realize that measure of angle 2 is bigger than x, I know where 2 falls in this hierarchy. It falls right in front. So we have measure of angle 2 is bigger than all of this. And we said measure of angle 1 gets put right there. And so we have our entire order as I wrote here. All right, Akshay, you had a question?
Yeah, 16.
16? 16, once again, you have to pull the triangles apart to see where everything falls in place. So on number 16, I think we had to pull them apart. So we have to look at our different triangles. Well, we have measure of angle 1 is not 90. I don't know why I put that. I should have put 45, not 90. Measure of angle 1 has to be 45 because these two sides are congruent. This has to be 45 degrees. Well, using this triangle here, I said that measure of angle 3 has to be bigger than measure of angle 2. But don't forget that a triangle has to still add up to 180 degrees. So if this is 90 degrees, and this angle is bigger than this angle must be at least 1 degree bigger than 45 degrees, because that would give me a 46, 44 degrees, 47, 43, 48, 42. Can kind of see that pattern? That if I know 3 is bigger than 2, I know that 3 must be bigger than 45. And I know that measure of angle 2 must be less than 45. And since measure of angle 1 is 45 degrees, 45 must be smack dab in the middle here, and that's why measure of angle 3 is bigger than measure of angle 2 is bigger than measure of angle 2. Does that make sense?
Yeah.
Cool. Other questions from the homework? Sabrina.
Number 14.
Number 14. That one's a 3-dimensional drawing. I think I even put in there that it was a three-dimensional drawing. Did I put that somewhere in there? And I wanted to do that because if you found out this was 80 degrees, you'd realize that 80 plus 55 plus 55 doesn't equal 180. But that's okay if it's a three-dimensional drawing because this isn't a two-dimensional thing where the things are coming together. It is more like that. That's why I want to do that so people didn't freak out because this was 80, 55, 55. Regardless, you have three triangles. Three individual triangles with the angles or the sides we're looking for. So I pull apart from every one of those triangles information I can get from it. So if this is 55, this is 55, and this is 70. That means the one across from 70 must be our longest line there. And that is VA. So our segment VA must be bigger than, well, this one's 55 and this one's 55, so the other two sides must be the same length. So the opposite one of 55 is CV, and the opposite this one is CA. So CA equals CV, but the only thing I really care about is VA is the biggest one out of the two. Then I go to my next triangle, and I say, well, this is 50 degrees, this is 80 degrees, this is 50 degrees. That's how I got the 80. And so I said the one opposite 80 must be my longest side, so that's my VB. And VB is bigger than the other two sides, which was VA and AB. Well, look at this. This VA is over here, right? It's here too, so VB must be bigger than VA. Now I do that last triangle. I look at 55, 55, 70. The one opposite 70 is my biggest line, and that's my AB. And it says that AB is bigger than the other two sides, which included CA and CB. Well, AB falls right here, where VB is still bigger than AB. So VB must be my biggest one. So this is the prime example of how I have to pull the three triangles apart and put the information back together. But you have to do it with individual triangles every time. You only can do one triangle at a time. If you looked at my answer key, I never went above going one triangle at a time. Other questions? Yeah, Sabrina.
For number 12,
Do you have a specific question?
just kind of how you got the answer OA.
Okay. So 12 is the exact same procedure. Exactly the same. In fact, every one of these, I can't make them hard. I can't make these problems hard because all you need to do is figure out which triangles comprise your drawing. So I started off with this triangle here. I started off the one with 10 degrees. And I said, based upon that drawing, this must be 80 degrees. 90 degrees is my biggest side, so that tells me that OC has to be the biggest out of those three sides. So I came with OC is bigger than OD is bigger than CD. Then I went to the next triangle. I went to the one that's 90 degrees. And I saw that this needed to be 81 degrees. Once again, I just had to list what's bigger and what's smaller. Well, the biggest angle is C here, so the side opposite is OB. OB must be bigger than OC, because OC is across from the 81 degrees, and our last one is BC. And finally, I do my last triangle, which set up that OA is bigger than OB is bigger than AB, and then I just put them all together. Well, if OA is bigger than OB, it must be bigger than all of these. And since OB is bigger than OC, it must be bigger than all of these, so OA has to be our longest line. And the only way we can discover that is to break it into three triangles, put down what information I know about all three triangles, and then put that information back together. Other questions? All right, then you can just work on the homework and ask questions about that later.